Hello everybody. We're in section 1.5, algebraic expressions, and our first job is to define a few things. So when we say algebraic expressions, what do we mean? Well, by definition, an algebraic expression, let me get this straight here, is a mathematical statement consisting of constants, which are numbers, variables, those are the letters, joined by operations of addition, subtraction, multiplication, division, exponents, and grouping symbols, by which we mean parentheses, brackets, and the like. So what is a term of a variable expression? Well, a term in a variable expression is a part of an expression that's joined to another part by the operations of addition or subtraction. That's it, addition and subtraction. So when we talk about a term, right, this is what we mean. Now, I would make a quick note. There are other words for parts of an expression. People seem to use the word term pretty interchangeably, just like it's in the regular English language. In fact, there is a big difference from what we know of as terms in the English language, and that is this. An algebraic expression, a term in an algebraic expression, is opposed to, let's say, a factor, which is part of an algebraic expression that's multiplied by another part. Okay? In an algebraic expression, we can have a part that is multiplied by another part. For instance, when we multiply together a number or a constant times a variable, we call that number a coefficient. So for example, if I write 3x, 3 is a factor of 3x in that 3 is multiplied by x. So you have to be very careful in the way that you state this. So what is the difference between a variable term and a constant term? Well, very simply, a variable term is a term that contains a variable, a letter that stands for an unknown number. On the other hand, a constant term is simply a term that contains a constant but no variable. So for example, if we wanted to name the variable terms of the expression 3b cubed minus 4b minus 2, there are two variable terms right here. The variable terms are 3b cubed and minus 4b. Notice, by the way, that I'm carrying the sign with the term. So this was negative 4 times b. The reason I think about it that way is because when I rewrite this expression, it's very helpful very often for me to write 3b cubed plus negative 4b plus negative 2. And note, by the way, that negative 2 is a constant term. There's no variable attached. Okay, so given all of that, what else can we do? Well, we want to be able to evaluate expressions when it comes to algebra. And so when it comes to evaluating expressions, what do we mean by that? Well, to evaluate an algebraic expression, what we really mean is to find the value of the algebraic expression by direct substitution. In other words, let's substitute in for the values of whatever the variables are. For instance, in number 2 here, the variables are a and b, and find out what the value of the expression is using our order of operations. So if we wanted to evaluate 3a squared minus 4ab, when a equals 5 and b equals 4, we will make the substitution, replacing a with 5 everywhere we see a, and b with 4 everywhere we see it. And of course, we have these expressions right here. This says by our order of operations we do anything parentheses, but well, everything in the parentheses is already done. So we would do exponents next. So we would be taking 3 times 25 minus 4 times 5 times 4. and then do the multiplication from left to right. 3 times 25 is 75. 4 times 5 is 20. 20 times 4 is 80. And so our result right here, the evaluated expression is -8. Let's try a couple more of these. When we evaluate these expressions, we can evaluate again by substitution. Let's take a look at this one. X cubed plus y cubed over x plus y. Well, we're going to take 2 to the third plus -3 to the third power. Be very careful. That negative is part of the exponent, divided by 2 plus -3. Now, that division bar acts as a grouping symbol. So anything that occurs above or below that division bar, we have to handle separately. So using our order of operations, above the division bar, we're going to take 2 cubed, which is 8, plus -3 cubed, that's -27. And of course, we're going to take 2 plus -3 in the denominator, using that grouping, giving us -1. Of course, 8 plus -27 is the same as 8 minus 27, and when we do that subtraction, we get -19 over -1. Division would come next, so we're going to reduce that, and we get +19 as the result. All right, one more. A squared minus 5 times the quantity a minus 2b minus c squared, when a equals -3, b equals 2, and c equals -1. Well, when a is -3, we're going to take -3 squared. Again, be very careful that the negative and the 3 both gets part of the exponent. 5 times -3 minus 2 times 2 minus c, which is -1 squared. Carrying out the order of operations right here, we work inside of our parentheses. We're going to take -3 squared, and we're going to be subtracting from that 5 times -3 minus 4 minus -1 quantity squared, and simplify just a little bit more. -3 squared minus 5 times -7 minus -1 squared. The little board doesn't like to cooperate with me here. Now we do some exponents. Of course, -3 squared means -3 times -2. That's +9. The negative goes away. Minus 5 times -7. Minus -1 squared means -1 times -1. That's +1. So in fact, we have 9 minus, we do some multiplication, minus 5 and -7 becomes plus 35 minus 1. If we do our addition subtraction left to right, 9 plus 35 is 44. Minus 1 gives us 43 as the result.